Hi everyone, this is Miss Moriarty and I'm here to discuss with us topic 9.4, which is all about the impacts of increase in greenhouse gases. Well, to start off with this topic, we need a good understanding of what is global warming and what is global climate change. Since now at this point we've gone over, right, what are our principal greenhouse gases, things like carbon dioxide, methane, nitrous oxide, water vapor, tropospheric ozone, CFCs, right? We know each and every one of those gases are going to contribute to our greenhouse effect, and the more concentrated amount of those then gases, we see a more enhanced greenhouse effect. So with a more enhanced greenhouse effect, our result is going to be an overall warmer Earth, right? Because we're going to see more of that infrared radiation being able to be re-radiated back towards Earth's surface. Now, as a result of our Earth, right, in terms of its global temperature increasing, we're going to also see the average weather over long periods of time, or climate change over periods of years or decades. And as a result of both global warming, global climate change, we are going to see major changes around the world, such as rising sea levels. We will see altered, right, biogeochemical cycles, right, our nitrogen, carbon, phosphorus cycles. We'll see an overall decrease in biodiversity, more infectious diseases, and so on. So how do we know, right, that we are currently experiencing warmer temperatures than what we have before, or experiencing differences in climate? Well, it is because now, after many studies, we tend to see kind of the same pattern, and that pattern is the fact that we have seen carbon dioxide levels rising steadily since around, let's say, 1958 or so. We could see in this graph here, right, our monthly averages of carbon dioxide kind of fluctuate, right, throughout each and every year. That kind of constitutes, right, the seasons, right, where we might see more vegetation captures more CO2, right, during those winter or fall seasons. Lots of those vegetation go dormant, so we tend to see higher carbon dioxide levels during those years, but we can see kind of a steady trend upwards over time. Now, we know a lot of those greenhouse gases tend to come from anthropogenic sources like fossil fuel combustion, the use of fertilizers, CAFOs, and so on. So who is emitting more of those around the world? Well, the largest contributors are going to be developed or rapidly developing countries around the world. So you can see in the left-hand graph here, right, the United States and China together, we both have produced millions of metric tons of CO2 into the atmosphere. But what's really interesting is when you look at a per capita basis, not always is the country with the greatest total amount of CO2 going to be the greatest per capita. Right, we can kind of see Saudi Arabia, Canada, South Korea, not necessarily on the larger total, but the per capita basis is quite large. Now, what are some overall consequences of increasing our greenhouse gases, enhancing the greenhouse effect, and as a result, we experience, right, that global warming and climate change? Well, one of the big factors here is going to be the rise in sea level. And how do we wind up getting a rise in sea level? With increased greenhouse gases, this comes a much warmer climate, and as a result, in our poles, where we find lots of ice sheets as well as glaciers, they're going to melt far more than what they normally do. This then water is going to flow into the ocean, and it winds up leading to sea level rising. But be careful when you talk about what is actually melting and what's going to contribute to the sea level rise, because it's actually going to be that land-based ice sheets and glaciers that forces that sea level to rise, not necessarily the sea ice that's floating around in the ocean in that Arctic area. Now, with combined of the melting of ice sheets and glaciers, we can also see a phenomenon known as thermal expansion. And these are actually water molecules usually found at the ocean surface. When they are heated, we kind of see them slowly move apart, and you can kind of see that in this little animation here. And as they continue to expand like that, that can also aid in that sea level rising. So in the graph down below, where we see 1993 to 2018, we could see global sea level here is this gray line. Now here in a couple of those different lines, they indicate some different factors that could contribute to our sea level rise, such as that thermal expansion. Here would be our added water of our melting glaciers and sea ice, but when we combine those two, we could see an overall increase, right, in our level of sea rise over time. Now, with rising sea levels, what is the cost of that? That would obviously be flooding of coastal ecosystems. So things like mangroves, salt marshes, estuaries, where we see that mixture of fresh water and salt water. And if we lose those habitats, we most likely lose numbers of species that depend upon that type of habitat. We also know that we're going to see a loss of species in that more Arctic area, especially if they are very dependent on the availability of sea ice in order to hunt their prey and navigate around their ecosystem. We'll also see a loss of what's known as the thaw and freeze cycle that glaciers tend to go through whenever they go through seasons in those biomes. This can deprive that ecosystem and even maybe human communities that might depend upon that melting and rethawing of that water for their water source. Now we can also see if there's going to be coastal flooding, that also means a relocation of human populations. So we're going to see an increase in flood frequencies, which then relates to maybe higher insurance, repair costs, loss of property. So right, that's where kind of like that economic damage comes into play. We probably would see greater cases of saltwater intrusions, since now we see, right, a rise in sea level, more saltwater pushing into groundwater, maybe contaminating groundwater resources, forcing people to move more inland and, move out of those more coastal areas. And lastly, right, another consequence of our increase in greenhouse gases, global warming, and so on, is pretty much what we talked about towards the end of Unit 8. And this was vectors, right, that are going to carry and transmit certain diseases. So common vectors like mosquitoes, ticks, and fleas are going to be able to spread much more easily and to more vast areas, especially if our tropical and subtropical biomes are now going to, right, move more northward or more southward. So now those warmer temperatures allow for those insect-transmitted diseases to spread to parts of the world where they normally wouldn't. And this can pose a great risk, obviously, to human health, especially in places that are not prepared for those types of diseases. So here is our practice FRQ for 9.4. Take a moment and you can pause the video at this point. You want to answer in your note packet and on the Edpuzzle. Okay, at this point you should have paused the video and answered our Edpuzzle. So here in our Edpuzzle we have our graph. Here it says changes in average temperature for global as well as Arctic, which was the dotted line here, between 1900 and about 2016. Here you can see the dotted line, however, that was our 1981 to 2010 average. Here in the first part, you had to describe the difference in the change in temperatures in the Arctic as well as global temperatures from 2000 to 2016, as well as identify one impact global climate change can have on human health. In terms of A, you could have said that temperature is increasing or warming faster at a much greater rate in the Arctic than it is globally. Right, the Arctic is going to be a biome that's going to be impacted by global warming and climate change at a much faster rate than really any other place in the world. B, we could have said, remember, the increase in spreads of vectors that carry diseases, we know are going to move from more tropical areas closer to the poles, right, posing a great risk to human health. We could say an increase in temperatures is going to increase, right, our algal blooms, maybe waterborne diseases. We could say an increase in exposure to more maybe extreme heat or maybe cold runs the risk of spreading certain illnesses or death due to exposure. Decreased water quality, right? We said with more floods could come more saltwater intrusions. This then leads to more contaminated drinking water, and so on. Alright everyone, that is our video on 9.4. Just leave a question at the end, please, and hopefully I will see you tomorrow.